In the previous videos, we discussed symmetric and skew symmetric matrices, and based on that, some theorems and some examples we discussed. And the last concept of this topic, that is, my dear students, invertible matrices. So I am going to discuss what is meant by invertible matrices. So my dear students, if I have the any matrix, if A is any matrix, if A is a matrix, if A is a matrix of order m. My dear students, if A is any matrix, that is a square matrix. So if A is you can write, or else you can write it as if A is the square matrix, if A is a square matrix, if A is a square matrix of order m. My dear students, please remember, here I am not writing of the order m cross n. I am not writing. Why? Because already we discussed. Square matrix means what? Square matrix means in a matrix the number of rows is equals to number of columns. So instead of saying, here it is, if I take the matrix of the order m, means I should instead of saying m cross m, simply what I told, of the order m. So if I write simply, if A is a square matrix of order m, means you should understood that it has m rows and m columns. So in short, we will write the simply I write only once I write m, the square matrix of order m. So now come to the concept. If A is a square matrix of order m, and if and if there exists a matrix B of the same order, if there exists another one, if there exists a matrix B, if there exists another one, you can write. So if there exists another matrix B of the order, if there exists, or else I write like this, if there exists another matrix B of the same order, in such or in the same order, such that AB is equals to BA is equals to I. My dear students, if this condition satisfies, then we can say that such that AB is equals to BA is equals to I, then A is called as, here it is, A is, or else here it is, B is called as inverse of A. B is called as inverse of A, and in this case, in that condition, A is called invertible. A is called invertible, and it is denoted as, that is, B is equals to A inverse. Clear, my dear students? So what is the definition, or what is meant by A invertible? I told, if A is a square matrix of order m. So A is the any square matrix. If we have any, A is the any square matrix of order m. If there exists another one matrix B, of the same order, the order should be same, such that if you multiply with A, this exists, whatever existing matrix, if you multiply with this A into B, if you multiply, or if you take B into A, after multiplying this, you should get it as the identity matrix. I means what? I means identity matrix. So if you got this, in such cases, A is called as the inverse of B, and similarly B is called as the inverse of A. Then B is called the inverse of A. And in that condition, in this condition, my dear students, A is called as the invertible, and it is denoted as, here it is, and here it is, inverse is denoted by B is equals to A inverse. B is called the inverse of A, and generally we will denote it as the B is equals to A inverse. Clear? I hope you understood. And now my dear students, I'll take one example so that easily you can understand. So inverse means what? For any matrix A, if there exists another one matrix B such that after multiplying those two, if I multiply A into B, if I got A into B or else B into A if I multiply, then I should get it as the identity matrix. If I got the identity matrix, then in such case B is called as the inverse of A, and my dear students, A is called as the invertible, and even A is also called as the inverse of B. Clear? So now, and it is generally will denoted as like this, A to the power, here it is minus 1, like this, A inverse. We will write like this, and we will write as A inverse. Clear? Now my dear students, I'll take one example so that you can easily understand. For example, here, for example, I'll take a matrix A. So A is equals to, I am taking here 2 3 2 3 1 2, and another one matrix I'll take B as, here it is my dear students, here I'll take it as 2 2 minus 3 minus 1. Clear? So these are the two matrices I am considering here. It is. Now my dear students, I check whether these two are invertible, that is inverse or not, whether B is the inverse of A or not, we will check. So first my dear students, what I said here is, if A is any square matrix, this is a square matrix, if A is any square matrix, and if there exists another one matrix B of the same order, this is also matrix of the order 2 cross 2, 1 to 2 rows are there, 1 to 2 columns are there. So this matrix is of the order 2 cross 2, and also my dear students, the order of this matrix is also 2 cross 2. So both are the same order. Now I should check if I multiply these two whether I am getting the identity matrix or not, that I am going to check here. Please concentrate my dear students. Simple it is, very concept is very simple. So multiply these two. First I will multiply my dear students. 2 3 1 2 into here 2 minus 3 minus 1 2. And my dear students, already we know how to multiply the two matrices. The multiplication of the two matrices is done by rows by column. That already we discussed. So now my dear students, here it is. First row, first column, and always I told that whenever you are applying the multiplication operation, in such case the number of rows in this matrix must be equals to the number of columns in this matrix. Here it is, the number of columns in this matrix, the number of columns in this matrix must be equals to the number of rows in this matrix. Here how many columns are there? 1 2. Here how many rows are there? 1 2. So therefore multiplication is possible. Please remember, whenever we are multiplying the any two matrices, always that obeys the one condition. What is that condition? The number of columns in this matrix must be equals to number of rows in this matrix. If those two values are equal, then only multiplication is possible. Here 1 2, 2 columns are there, 1 2, 2 rows are there. So therefore multiplication is possible, and multiplication is done by multiplying the rows into column. So therefore rows into columns, first row, first column. So 2 2s are 2 into 2. Next my dear students, plus 3 into minus 1. First row, first column. 2 into 2, 3 into minus 1. First row, first column. First row, second column. So therefore leave some space. First row, second column. 2 into minus 3 plus 3 into 2. Clear? And next similarly my dear students, first row, first column is over. First row, first column I wrote here. First row, second column also I wrote here. 2 into minus 3 plus 3 into 2. Next my dear students, second row, here it is, second row, first column. So 1 into 2, second row, first column. Clear? So 1 into 2 plus, here it is, 1 into 2, 2 into minus 1. First row, second row, first column. 1 into 2 plus 2 into, here it is, plus 2 into minus 1. Next second row, second row, second column. And here this 1 into minus 3, 1 into minus 3 plus 2 into 2. Further simplify this, my dear students. So after simplifying this, you should get it as the identity matrix. So clearly further simplify this. If you simplify this, you will get, here it is AB is equals to, here it is 2 2s are 4 and plus minus minus 3. Next here it is 2 3s are 6 minus 6 plus, here it is 3 2s are 6. Next my dear students, 2 into 1 is 2. Next plus minus minus 2. Next here it is minus 3 and next plus 2 2s are 4. Clear? So therefore here if you simplify this further, you will get here 4 minus 3 is 1, plus 6 minus 6 got cancels 0, plus 2 minus 2 got cancels 0, minus 3 plus 4 is plus 1. So this is what your identity matrix. So therefore my dear students, if you multiply AB, you are getting as the identity matrix. What I told. So here it is, AB must be said, AB must be, after solving the AB, we should get it as the identity matrix. Even if I solve the BA, then also I should get it as the identity matrix. So now calculate the BA matrix students. So BA is equals to, what is the matrix B here? 2 minus 3 minus 1 2. This is your matrix B. 2 minus 3 minus 1 2 into the matrix A is 2 3 1 2. Clear? Now multiply these two matrices. Again here it is, we should check before multiplying any two matrices, we should check whether the number of columns in this matrix is same as the number of rows in this matrix or not. That we should check. So here it is 1 2. 2 columns are there. 1 2. 2 rows are there. So therefore multiplication is possible and the multiplication is done by row by column. So first row, first column. So therefore BA is equals to, here it is 2 into 2 plus minus 3 into 1. First row into first column. First row, first column. Next first row, second column. So leave some space. 2 into 3 plus minus 3 into 2. Clear? My dear students. First row, first column. First row, second column. This I wrote. And next, second row, first column. Minus 1 into, second row, first column. Minus 1 into 2 plus 2 into 1. First, second row, first column. Minus 1 into 2, 2 into 1. Next, second row, second column. Second row, second column. Minus 1 into 3 plus 2 into 2. Clear? Don't be confused. Here sometimes I am writing, here also I wrote the bracket just for the sake of the simplification. Clear? And now my dear students, this is BA is equals to, here 2 2s are 4 plus minus minus 3. Next 2 3s are 6 plus minus minus 3 2s are 6. And next here is plus 1 into 2 is minus 2 plus 2. Minus 2 plus 2 and here it is minus 3 plus 4. Clear? Further, if you simplify this, you will get 4 minus 1 is 1. 4 minus 3 is 1. 6 plus 6 minus 6 got cancels 0. Plus 2 minus 2 got cancels 0. Minus 3 plus 4 is 1. So 1 0 0. This is nothing but identity matrix. Clear? Identity matrix means what? That we discussed in the case of the types of the matrices I explained. Identity matrix means all the non-diagonal elements must be 0 and the diagonal elements must be 1. Clear? That we can call it as the identity matrix and that is denoted by the symbol I. Clear? So therefore BA is equals to I. My dear students, here BA is equals to, also I am getting identity matrix. Even AB is equals to, also I am getting identity matrix. So therefore we can say here it is A is, here it is B is the inverse of matrix A. Clear? So I explained this concept to understand the invertible of the matrices. So my dear students, now you can easily understand, for any matrix A, this is the one matrix. For any matrix A, if there exists another one matrix B of the same order as in such a way that after multiplying AB and even BA, after multiplying this, if you are getting the identity matrix, then in that case we can call B is the inverse of A, you can call, or else you can call A is the inverse of B also you can call, and in this case, in the such case or such conditions, A is called as invertible. So this is the concept of the invertible matrix, students. I hope you understood. Please pause the video to note it down. So next, my dear students, please keep in mind note. What is the note means? Note is, my dear students, first note I am going to discuss for a rectangular matrix. For a rectangular matrix. Rectangular matrix, the inverse we cannot find, my dear students, because for any matrix A, if it wanted to inverse, or if I wanted to find the inverse, means the condition, what is the condition? AB must be equals to BA is equals to identity matrix. But my dear students, if I take the any rectangular matrix, then what happens? Here AB may possible, but in the case of BA, multiplication is not possible, because rectangular matrix means what? Square matrix means the order must be A and B have the same order. But in a rectangular matrix, what happens, my dear students? It is not possible in a rectangular matrix. Rectangular matrix means in the rectangular matrix, the both A and B matrices may not have the same order. So therefore multiplication is not possible. So therefore in the rectangular matrix, inverse does not exist. In a rectangular matrix, inverse does not exist. Please keep in mind, does not exist. So always whenever you are applying the inverse, whenever you are finding the inverse of the matrix, always the matrix must be a square matrix. Clear? Next, my dear students, second note is here A is called as the inverse of B and B is called as the inverse of A. This is the second note. And next, my dear students, third note, here you can call, or else here you can call A is the inverse of B, or, and also you can call here it is B is the A inverse, or A is the inverse of B, you can call. Next, my dear students, the third note is, it's not the condition that always for any matrix we may or we may not find the inverse. It is not condition that for every matrix we can, it is not the case that for every matrix we cannot find the inverse. It may or may not. That we will discuss in the while solving the questions. In that case, we can easily understand. Clear? This is the concept of the invertible matrices. And now, my dear students, here already in this example we have the matrix A, and also I took the ready-made we took the matrix B. So the inverse of the matrix I already calculated, so that I took here this. Directly I taken B just to notice whether this is the inverse of not this matrix is B's matrix is, whether this is inverse of this A matrix or not, to check. For that reason directly I took this matrix B. But in examinations what they'll do, they'll give you only one matrix, they'll give you the matrix A, they'll give you the one matrix, and then they will ask you to find the inverse of this. So directly here already I took and I wrote. But my dear students, in the examinations what they'll do, they'll give you the one matrix and then they'll ask you to find the inverse of this matrix. So how to find the inverse of that matrix? That's very important. And in every examinations they'll ask such question. They'll give you one matrix and they'll ask you to find the inverse of the matrix A. So my dear students, there are several methods to find the inverse of the any given matrix, and please keep in mind for every matrix it's not possible to find the inverse. I mean, it's not the condition that or necessary that for every matrix there should exist an inverse. Sometimes it may exist or it may not exist. That we'll discuss later. In future we'll discuss. While discussing, I am going to tell whether the matrix inverse of the matrix exists or not. That we are going to discuss next. So my dear students, as of now, what I told here is A is the any matrix. If I wanted to find the inverse of this matrix, there are several methods are there. But as of now, or as considered to your syllabus, we can use the elementary operations. So what is mean by elementary operations, that I will discuss now. Clear? So next, my dear students, next the heading is elementary operations. So we will discuss the elementary operations. So you can call it as the elementary. It is just the, you can consider generally, you can take it as the rules. To find the inverse of the any given matrix, we have some rules. So what is that rule? By using that rule, I am going to find the inverse of the any given matrix. So that we will discuss, my dear students. The next concept is here elementary operations. You can call here it is here elementary operations. Elementary operations, or you can call, my dear students, transformations. Clear? So, or you can call it as the transformation of a matrix. Transformation of a matrix. So this is your heading they given to you in your NCERT textbook. So now we will discuss what are the, here it is, transformation. Please remember, my dear students, this I am going to discuss. These transformations or operations are helpful to us to find the inverse of the any given matrix. So this is very, very important. Definitely for 3 marks there will be one question. Find the inverse of the matrix by using elementary operations. Definitely one question will be there. So please try to practice such type of question that I am going to explain now. So my dear students, first we will check what are the rules or what are the transformations, or actually we should not use it as the rule, but to understand purpose we can think that, we can assume that as the rules, or you can call it as the elementary operations. So my dear students, here there are total, you can have 6 operations. So what are those? Now I am going to discuss. So my dear students, first one here, in a matrix you can interchange any 2 rows or columns. So R means what? R means, Ri means this is the one row and this is another one row, corresponding row you can take, or else here this Ri means ith row, J means jth row. And next I will discuss Ci and Cj. C means column and Ci means ith column and Cj means jth column, like that. So my dear students, I'll discuss. So if I have the any matrix like this, so in this case, this I can call it as the row 1. This already we discussed, just I am repeating. So just revision I am doing. So this is, you can call it as the row 2, my dear students. This we can call it as the row 3. Clear? And now this we can call it as the column 1. This we can call it as the column 2. This we can call it as the column 3. So my dear students, just understand what are the operations we can apply. How to apply, how to find, that I have discussed later. But as of now, what are the rules are there? What we can make to find, the inverse of the any given matrix, that I am discussing here. It is. So first one, what is the first condition, my dear students, or first transformation? You can interchange any rows, you can interchange. Either you can write this row you can write first and this row you can write second, or this row you can write last and this row you can write here. It means that you can interchange any two rows, my dear students. So the nothing will happen to this matrix. You can interchange any two rows. Clear? You can interchange any two rows, or my dear students, you can interchange any columns also. That will denote like this. You can interchange Ci and Cj. Ith column and jth column you can interchange, or ith row or jth column, jth row you can interchange. So it is nothing but I can write the first row, I can write here, and then this third row I can write here. Like this you can interchange. Clear? Or else you can interchange column also. First column you can write here, and this column you can write here. You can shift the columns, or you can shift the rows. This is the first rule, my dear students. And next, second is, to the elements of the any row you can multiply with the constant k, non-zero constant k you can multiply. It means, my dear students, to the any row of the given matrix you can multiply with the non-zero number. With the non-zero number you can multiply, with any row you can multiply. Therefore I wrote here this. So for the any row you can multiply with the non-zero number you can multiply, my dear students. To the any row you can multiply with the non-zero number, or to the any column here you can multiply with the constant. For any column you can multiply with the non-zero number. Clear? So then also the nothing will harm to the given matrix. This is the second operation. Next, my dear students, the third operation is you can add, that is you can add the elements of any row. Here it is. You can add elements of the any row with the corresponding rows by multiplying with the non-zero constant. It means, my dear students, Ri changes to k into Rj. So it means if I have any row, to this row I can add with corresponding row. Corresponding means either this row or this row. To this row you can add with corresponding rows, that by multiplying by the to these elements, to this row, to the corresponding rows, any row you can take, to that I can multiply with the non-zero constant, and then after multiplying this, then I can add these two rows. Clear? So therefore here the addition here is, we can add any row, any elements of the any rows, corresponding elements of the rows multiplying by the non-zero constant. It means, I explain once, to the any row, my dear students, you can add with the corresponding rows by multiplying with constant. Clear? And similarly for columns also, that is Ci changes to Ci plus k into Cj, where k is the non-zero constant. So these are the rules we have, my dear students. This we can call it as the elementary operations or transformations we can call. So why I am discussing this means, as of now you may have confusions, but while solving the problems you will come to know why I am discussing all these conditions. Clear? But as of now you should understand, for the any matrix you can interchange the rows. What that is? First row you can write the first row here, that is first row you can write here, and this row you can write here. Like this you can interchange the column also. And next, my dear students, to the any row, to the elements of the any row you can multiply with the non-zero number. Similarly for the columns also. And next, my dear students, to the any row you can add to the elements of the any row you can add with the corresponding elements of the rows by multiplying with the non-zero, so that is constant number. Now but that should be not equals to 0. Non-zero number you can multiply. So these are the operations. So total, my dear students, you can have, so you can count it as the 6 rules or 6 operations you can take. 3 for the rows and 3 for the columns. Clear? I hope you understood. And now my dear students, we will discuss questions based on these elementary operations. And please remember, these operations I am going to use to find the inverse. They will give you one matrix A. To that matrix, if I wanted to find the inverse of this, means how to find the inverse of this, that procedure I am going to tell. But before that, for any matrix A, to find the inverse of this, we will use this rule. By using these operations, I am going to find the A inverse. Clear? I hope you understood, my dear students. First of all, I'll take one example so that easily you can understand. So I'll write the question. So what is the question? By using elementary transformation. So I'll discuss one question so that you can easily understand. So here it is, the question. By using elementary transformation, by using elementary transformations, find the inverse of the matrix. Find the inverse of a matrix. Find the inverse of a matrix. A is equals to 1 minus 1, 1 minus 1, 2, 3. 2, 3. So my dear students, very important. This question was asked March 2014 and March 2016. This question was asked in March 2014 and March 2016 in Karnataka board examination, second PC. They asked. So this question was asked for the 3 marks. So very important. Definitely in your question paper, such type of questions will be there. So please try to practice such type of questions for 3 marks. Very important, my dear students. And we are very simple also. So now come to the point. So how to find the here inverse of the matrix. So my dear students, as earlier only we discussed what is the meaning of the inverse or what is invertible, that we discussed. Now I am going to tell you how to find the inverse. My dear students, please see here, by using elementary transformations. So what are elementary transformations? This is what we can call it as the elementary transformations. We should use this. By using these transformations, find the inverse of a matrix. So here my dear students, we have A is the one matrix they given to you. So you should find the another one matrix such that I'll take it as a or else A inverse will denote like this. So therefore I'll write like this. So for the any matrix A, we should find the A inverse. So if I find the inverse, means that must be equals to I. Clear? A inverse into A is equals to I. So here what I repeat, find the inverse of a matrix A. I wanted to find the inverse of this matrix A. Clear? So to find that, my dear students, first there are two procedures we can follow, two methods we can follow. First I am discussing the how to find the inverse of the any given matrix. So my dear students, first you should think how many operations are there? 6 operations are there. So 6 operations, these 3 for the rows and these 3 for the columns. Clear? So before solving the inverse of the matrix, keep in mind whether you are interested to apply the rows transformations or you are interested to apply the column transformations. This is very important. I am telling this because, my dear students, whenever you are applying, if you are interested to apply the row transformations, always you should use, until you complete the question, you should use always these 3 only. I mean only for the row operation only you must use. If you are interested to find the column operation, means until the question completes you should use these 3 operations only, that is column operation only you should use. So it is not the case, or you cannot use in the same problem you cannot use both operations. Once you can use row and once you can use columns, likewise it's not possible. Clear? So whenever you are solving the question, first only you should know whether you are applying the rows operations or column operations. If you are applying the rows operations, my dear students, if you are interested to apply the row operation means you should write it as, here it is elementary operations, you should write it as a is equals to I into a. Clear? A is equals to I into a. So row operation here it is. So whenever solving the inverse of the matrix A, if you are interested to apply the row operation means until the question completes you should use these three only. If you are applying the column means you should use these three only. Okay, clear? So now my dear students, so if I wanted to apply the row operation means first you should write it as the given matrix, which first you should, the procedure I am telling here. So if I wanted to apply the row operation means to find the inverse of the matrix, if you are interested to apply the row operation means first you should write it as A is equals to I into A. Clear? After writing this, my dear students, you should write the A in place of A. You should write the given matrix, and then you should write 1 0 0 1, and A here it is as it is. Clear? Now, my dear students, after this, you should convert the LHS. In the LHS, you have the matrix A itself. Clear? So you should convert that A matrix as identity matrix. Whatever matrix you have in the place of A, that LHS part, you should be convert it as the identity matrix in the form of I matrix. So if you wanted to convert the identity matrix, so in that case, to convert the LHS part, to convert this LHS part as the identity matrix, to that, in that condition you should use these any operations, these three operations you can use. Clear? Now you can understand why I explained these three. These three I explained because by using these three operations I should convert the LHS as identity matrix. So after converting this matrix as the LHS, that is LHS part, after converting this A matrix as the identity matrix, I can compare, then I can compare with, my dear student, I is equals to A inverse into A. And please remember, you are converting, first what you will do, my dear students, first I will write the, first I will think whether I am applying the row or column. If I wanted to apply the row operation, or if I am interested to apply the row operation means first your job is, the first step is you should write the matrix as A is equals to I into A. After writing A is equals to I into A, keep the A, you should write A as it is, don't put this value matrix. But in the case of LHS, you should replace A as this matrix, whatever they given to you, that matrix you should write, and then in place of I you should write the identity matrix. So that is depending upon the matrix given order. If the matrix is made, if the matrix given to you is of the order 2 cross 2 means you should take the identity matrix as 1 0 0 1. Clear? And this A you should write as it is, and A, this here A you should write as it is A only, but here you should replace the matrix A. Clear? After that, what you should do? You should convert this LHS part as the identity matrix. Clear? And whenever you are converting the LHS, the same case you should apply here also. It means through this identity matrix also you should convert it, whatever operation you are applying, here also you should apply the same operation simultaneously. So what you should do? This LHS part you should write it, you should convert it as the identity matrix. The converter converts whatever you are converting. In that case, you should obey or you should follow these three rules. By applying these, any among these two, that is depending upon the situation. So in that case, you can use any these three rows or these three columns. operations. By applying that, you should convert it as the identity matrix. After converting it as identity matrix, you should compare with the whatever you are getting. You should compare with I is equals to A inverse into A. So in the place of whatever you have the A inverse, in the place of A inverse, whatever you will get the matrix, that is nothing but your A inverse. Clear? Like this, we will solve to find the inverse of the any given matrix. This is just procedure I explained. While solving the questions easily, you can understand. And my dear students, if you are applying the row operation means, keep in mind first you should write it as A is equals to I into A, and then while converting this LHS as an identity matrix, in that case always you should use these three rows only, row operation only. So you cannot use, in that case you cannot use column operation. And next, first you should fix yourself that whether you are applying row or column. So if you want to wish, or if you are interested with column operation means, here my dear students, here the first step you can write A as A into I. Clear? If I wanted to apply the column operation means, first you should write it as the A is equals to A into I, and again here this LHS part you should write, LHS part you should replace with the given matrix 1 minus 1 2 3 you should write, and A write as it is, and but in the place of I you should write it as identity matrix. After writing that, you should compare, after solving again the LHS part, you should take it as the, you should convert it as the identity matrix, and that conversion is done by using these rules, these operations. And if you are using the column means, you should take only, you should use this through, you cannot use this row operation. Clear? So therefore you should use this. After using all these three operations, you should convert the LHS as the identity matrix. After converting this LHS as the identity matrix, you should compare with here I is equals to A inverse into A, or else here this you can have it A is equals to A inverse. You should compare with this. After comparing with this, in the place of A inverse, whatever matrix you will get, that is your A inverse. Like this you should solve my questions. So don't afraid, just this is the theory part I explained, that what I am going to use. Clear? After solving the question you will come to know. Clear? So very simple is my dear students. So first I will solve the question. So what is that question? Find the inverse of the given matrix. To find what I told, first we should write, my dear students, first we should write it as, I'll write here, first we should write it as so my dear students, to the elementary row operation we write, please keep in mind here they didn't mention, just they told that by using elementary transformations, they didn't told you that you should apply column operation or you should apply row operation, like that they didn't told. Simply what they told, you should use the elementary transformations. So elementary transformation means this is also, these three also elementary transformation, these three also elementary transformation. Either you can use rows or you can use columns, but generally I am going to use rows only, my dear students. So now what I told, to the elementary row operations we write. So first step only I told you that if I wanted to apply the row means, until the question completes we should use row operations only. So now I am using row operation. To the elementary row operation we write A is equals to I into A. If you are using column means, you should write it as A is equals to A into I. Clear? So now my dear students, what I will do here is, this LHS I should convert, this LHS part I should convert it as the identity matrix. So first I write A. What is here this? This implies, what is the matrix A? A is 1 minus 1 2 3 is equals to, here identity matrix is 1 0 0 1, and we will write the A matrix is as it is. Clear? And now my dear students, my aim is to convert this matrix as, this LHS part, LHS matrix as the identity matrix. And please keep in mind, when converting the identity matrix, we will follow. Before that, my dear students, what is identity matrix? Identity matrix is of the order, this is the matrix of the order 2 plus 2. So I should convert this part or this LHS matrix in the LHS position, whatever I have the matrix, this I should convert it as the identity. So identity matrix, how will you write? 1 0 0 1. Clear? So my dear students, first always you should convert the elements like this pattern. Clear? It means first we should make this element as 1, next this element as 0, this element as 1, this element as 0. If you go this pattern, then that is very useful. The simplification will be easier. So therefore this is this, in this pattern you should convert the elements, my dear students. I hope you are getting. So first in this matrix, this and this. Clear? So always keep in mind, my dear students, to convert this matrix as the identity matrix, I will go this pattern. That is, the first element should be 1 and second element I should make it as 0, this element as 1 and this element as 0. So already here this element is in this particular example, the first element, this is already 1, is already it's there, so no need to convert it. And next, my dear students, what is that here? Second, here in this place, it should be, we should convert it as the 0. Clear? Because the LHS part I am converting it as the identity matrix. So this element must be 0. But here it is 2 is there. To convert this 2 as 0, what are the operations I can make, that we should think. So my dear students, we have these 3 rules. So by using these 3 rules or 3 row operations, we should make it as 0. To make this 2 as 0, we should think in mind. So first of all, my dear students, you can observe here this 2 is there. So here 2, my dear students, here 2 is there. To make it as 0, what are the possible? See the above rows and below rows. Below is no rows, so leave that. Here above 1 row is there. Here you can observe, here 1 is there. To this 1, can I add to this 1? If I multiply with 2, my dear students, to this element, here I write here, to this row 1, to these elements, if I multiply with 2, 2 ones are 2. So now, my dear students, if I subtract means, so what, if you simplify this, what you will get? 2 minus 2 equals to 0. Clear? Then this element will become 0 here. Is it? So therefore, like this you should think. So what I will do, my dear students, here I will apply the operations here, because already we know we can, here this addition, you can take here this. Please come to here. Already what is this element? 2 is there. Plus, my dear students, I am multiplying with 2 and RJ means you can, this is row 2, I can take row 1. So here it is 1. So 2 plus 2 will become 4. But I don't require 4. I should get it as 0. To make it as 0, what I will do, my dear students? 2 plus, or else I will multiply with minus 2. Minus 2 into 1. So what happens here? It is plus minus minus 2 into 1 is equals to 0. And this plus minus minus, you can write it as 2 minus 2 into 1. Also you can write, if you take minus sign outside. So like this you should think in your mind and then you should solve. So please solve the so many number of problems, then you will come to know how to convert or how to make these elements 0 or whatever we require, how to convert that we'll get. Clear? So I'll solve some questions still. After solving 3 or 4 questions, we will come to know, and practice is very important. After the completion of this video, you should also practice the exercise questions so that you can understand. So my dear students, now the operation I will write like this: R2 changes R1. I'm not making any corrections in the R1, that is any transformation I am not applying for the row 1. My aim is to convert this row 2. Clear? So my dear students, here row 2 Row 2 must be, this element must be 0. To become this element 0, what should I do? This row 2 must be as it is, row 2, but minus, here it is 2 into row 1. This 2, because if you, this is like, this will act as the formula. We are only making here formulas like this because to make this element 0. So here you can see here, this is row 2. We will write like this, row 2 changing. How it is changing? Row 2 will be as it is, minus 2 I am multiplying, minus 2 I am multiplying with row 1 elements. Clear? So after writing this, whether it is correct or not, to check that, once verify this. Here row 2, in the place of row 2, this is row 2 element, 2 minus 2 into row 1, in the place of row 1 element is 1. So now simplify this, 2 minus 2 is equals to 0. So my aim is to convert this element as 0. That's happening here. So therefore I framed the rule like this, or I think like this to write. So therefore my dear students, simplify this, how it will become. So and this is applicable for row 2. This is every, here it is, this row 2 and this row 2, we should apply the every element of row 2, we should follow this rule. Clear? And this rule means we should simplify like this. So now my dear students, write the column 1 as it is. This is 1 minus 1. I am not making any operations on the row 1. So don't write, simply write whatever we have the row 1, write that much. But to the row 2 it's changing. So how it is changing? Row 2, my dear students. Here row 2 will be changes. Row 2 is changing, row 2 minus 2 R1. So row 2 in the row 2 we will apply this rule to the every element of the row 2. First I will take this element. So what is that? I will solve here. So what is that? First row 2. What is the rule we have? R2 changes to R2 minus 2R1. Clear? So R2 changing here. This is our R2. So first I will discuss for the first element. So here what is the first element? Row 2. In the row 2 this element is 2. 2 minus 2 into R1. In the place of R1 what is the element I have? 1. 1. So this is equals to 2 minus 2 is equals to 0. Likewise, to every element we should apply, my dear students. So what is that? Next, we should take the row 2. Here it is. Row 2, this element already I discussed. And here it is, I got it as 0. I write here it is 0. I write here it is 0. Clear? Next, this element now. So what is this row 2? Again, row 2 is 3 minus 2 as it is into row 1. In the place of row 1 what I have? Minus 1. Simplify this. So here it is 3 minus plus 2 ones are 2. 3 plus 2 is 5. So therefore you should fill in this place as 5 because row 2 is changing here. Row 2 I am changing here. So therefore every element of the row 2 will we should use this formula. Clear? And now here it is, this is equals to, again row 1 is as it is, 1 0 as it is. Now again my dear students, row 2 is changing. So what is row 2? Here it is, in the place of row 2 here it is 0. Row 2 is 0 minus 2 as it is into row 1. What is row 1? 1 here. Clear? So therefore 0 minus 2, my dear students, minus 2 into 1 is minus 2. 0 minus 2 is minus 2. So therefore in this place we should write it as minus 2. Clear? I hope you understood. Next, my dear students, this element. So row 2, in the place of row 2 what is the element we have? 1 minus 2 into R1 is, in the place of R1 what we have? 0. So therefore 1 minus 2 into 0 is 0. So 1 minus 0 is 1. So therefore here write it as 1 and this A is as it is. Clear? And next, my dear students, this next, please see here, observe here. What I told, my aim is to convert this LHS as the identity matrix. Here 1 is there and I told you to go in this pattern. Is it like this? In this pattern we should go. Here it is 1, here it became 0. Now this element we should change. And this element here, this 3 is there, but I should in this case, my dear students. Here 1 is there, here it is 1, here it is 0. Now this element should be changed, and this element, what should it should be happen, instead of 5 it should be become 1, because I am converting as the identity matrix. 1 0 1 0, and this element in place of 5 we should get it as 1. In place of 5, if I wanted to get 1 means, what I will do, my dear students, to this row 2 I multiply with 1 by 5 into R2. To this element, to this 5 element, if I multiply with 1 by 5, my dear students, this 5 got cancels and we will get 1. So instead of 5 it will become 1 here. So therefore what I will do, my dear students, to this row I will multiply with 1 by 5. Clear? And like how I am writing, just you should think yourself, in place of 5 I should get it as 1. To get here 1, what should I do? I should multiply with 1 by 5. If I multiply with 1 by 5, I will get here it is 1. So therefore I should write the condition like this: R2 must be changes 1 by 5 into R2. Like this you should think, my dear students. Clear? And now simplify this. Here R1, I am not operating any operations on the row 1. So write the row 1 as it is, 1 minus 1. But here it is row 2 is changing. So in the row 2, 1 by 5 into R2. It means every element of the row 2 we should multiply with 1 by 5. 1 by 5 into 0 is 0. And next, my students, 1 by 5 into, here it is I am writing. So what is the second operation I have applied? Second operation is 1 by 5 into R2. So next here it is 0 into 1 by 5. Here it is 1 by 5 into 0. 1 by 5 into R2 element. 0 is equals to 0. And next, my dear students, 1 by 5 into, next this element, R2 element. 1 by 5 into 5 is equals to 5 got cancels, you will get 1. So therefore I will write here it is 1. Close this. This is equals to, next, my dear students, again in this case row 1 is as it is. Next, here it is minus 2. But for the row 2, what I told you, here it is, why we should multiply every element of the row 2 with 1 by 5. So minus 2 into 1 by 5. 1 by 5 into minus 2 is minus 2 by 5. Am I correct? Minus 2 by 5. So therefore, my dear students, this will become minus 2 by 5. And next, my dear students, 1 to this element, 1 by 2 into 1. 1 by 5 into 1 is equals to 1 by 5. So therefore in this place I am writing 1 by 5 and this A is as it is. Clear? And next, my dear students, here you can observe what is my aim. Don't forget that the LHS must be converting as the LHS, I am converting it as the identity matrix. Here it is 1, here it is 0, here it is 1, and next I should make this, instead of minus 1 I should get it here as the 0. If I got here 0, then my job is half done, because this LHS must be after making this as 0, LHS will become identity matrix. So therefore next, my dear students, next my aim is to make this 0. So when it will become 0, think yourself. To make minus 1 as 0, what are the operations I should apply? You should think yourself and answer me. Yes, here it is, being an online class you cannot answer, but at least think yourself. What will be the next operation? Clear? So my dear students, here to make the minus 1 as 0, this minus 1 as 0, I will take the help of this row 2. So my dear students, I will see, just for your understanding purpose I am solving here this. Here it is, minus 1 is there. So minus 1, it should be 0. So here it is 1. So if I add this, you will get, am I getting here it is 0, minus 1 plus 1, 0. To this element, if I add the element of this, minus 1 plus 1, I am getting 0, here it is. Clear? My aim is to become this element, I should convert it as the 0. To convert it as the 0, if I take the help of this row 2, so in the row 2 what should I do? I just to this element row 1 I should add with the row 2. So therefore I'll write here it is row 1 must be changes to, this row 1 must be changes to row 1. This is row 1 element, row 1 plus row 2. This is row 2, row 1 plus row 2. If you add row 1 plus row 2, you will get it as the 0. Like this you should think. And now this operation only I am writing here this. So next my dear students, here R1 changes to R1 plus R2. Clear? You can add my dear students. So here it is. If you add these two, here I am getting here it is. Here this after this I am writing here R1 changes to R1 plus R2. So this implies what is R1 my dear students? R1 is what I told. Here R1 is changing. So here this is your R1. So what is that R1? In every element of the R1 we should apply. Now here it is R1 changes to R1 plus R2. Clear my dear students? So this will become here it is row 1 is as it is. Row 1 is changing. So here it is 1. Here it is row 1 is 1 plus of minus 1. Row 2. Here it is 1 plus. Here it is 1 plus my dear students. 1 plus 0 is equals to 1. So therefore this will become 1. Row 1 changes to row 1 plus R2. Row 1 plus R2. So 1 plus 0 is 1. Next my dear students, minus 1 plus 1 is, here it is 0. And row 2 is as it is 0, 1. And this is equals to. Next here my dear students, this plus this I am adding here this. Row 1 changes to row 1 plus row 2. So this element plus this element. So therefore 1 plus minus 2 by 5. This element plus this element. Simplify this. If you simplify this, 1 plus minus minus 2 by 5. My distance here nothing is there means take it as, we can write it as 1. So now take the LCM. So here it is 5 and 1. LCM is 5. And here it is 1 into, we should multiply LCM already we discussed in the previous videos. I explained. So it is here 5 and 1 LCM is 5. And to this element, whatever in the place of denominator we have, to this element we should multiply with the number. We should choose a number so that after multiplying that I should get it as 5. So to this one, if I multiply with 5, 1 into 5 is 5. Similarly likewise, 5 into 1 is, where it is 5 into 1 is 5. So now multiply this. 5 into 1 is 5 minus 2 into 1 is 2. So 5 minus 2 is 3 by 5. So my dear students, in place of here it is 3 by 5. Next my dear students, 0 plus 1 by 5. 0 plus 1 by 5 is 1 by 5 itself, and the row 2 is as it is, that is minus 2 by 5, and next here is 1 by 5 into A is as it is. Here it is A is as it is. So now compare with, now my dear students, see here this, compare with I is equals to A inverse into A. So this is your nothing but this is your identity matrix. This is in place of A inverse you have this element, and here this A is as it is. So therefore my dear students, therefore A inverse is equals to 3 by 5, 1 by 5 minus 2 by 5, 1 by 5. This is your required A inverse. Like this you should calculate my dear students A inverse for any given matrix. Like this you can calculate the A inverse. And I think now you understood why I converted this LHS as identity matrix. This LHS, why I converted the in terms of the identity matrix, because to compare with this I is equals to A inverse into A. So therefore my dear students, comparing this with this, we can have the A inverse value as this much. So therefore I am converting this LHS as the identity matrix. Like this you can calculate. Very important my dear students, as in every A-level examinations, Karnataka State Board, they'll ask such type of questions for 3 marks. So please try to practice this. And now we will discuss, and in the next video we will discuss some more examples, similar type of questions. And please, if you have any doubts, please comment me. I will reply for that, and we will continue in the next video. Thank you. Please pause the video to note it.